All right, so in this video, I want to talk about some of my exploration with geometry nodes and how I'm using it to create customizable objects like this iPhone. I'm going to go through, I'd already done this video once and feel like I did it backwards because I started to explain this complex geometry node setup for the phone and then went into some of the basic ideas. So I'm going to do the opposite here. I just wanted to show like where we'll end up here. But for now, I'm just going to go into a different file and show you how to create like geometry nodes in general in case you don't have any knowledge at all. So the approach that I'm taking here is to just take a shape, go into geometry nodes. This is Blender 3.1. If you're using an earlier version, the nodes may vary. So what you can do is just select an object. You can make a plane. You can put it on something else, but you need to have an object selected because this is a modifier. And then hit New just to create new geometry node here. And this is your geometry node modifier, and this is the node setup right here. And all that we're doing right now is running a group input into a group output. And the way that works is it takes, in this case, the geometry, the cube that we applied it to, and runs it through to the output. And what you can do is add things that happen to it parametrically in between. So what I want to show you how we made the phone is we basically cut this and you can add a curve. So you start, you think about like modeling, going back to the cube. You think about modeling, and in general, things are like projections of shape, especially with something like a phone, or some sort of like extrusion with bevels on it. So the new iPhone has this kind of extrusion along an axis. So that's what we're going to do is we'll make a quadrilateral, which is just a rectangle. So if we just pipe that in, here's our quadrilateral. And we can rotate this to get it however we want. I'm just going to leave it set this way for now. Notice that I've severed the group input here, and now I'm just generating geometry, and really that cube that I started with is just a placeholder for this modifier now. So what this does then is it gives us the ability to change the scales. So if we have a width and a height, I can pipe those into the group input, and now my width and height are over here as a controller on the modifier. So now that we've got this edge curve, we want to do something with it to create the extrusion. So we can go and add search extrusion and just pipe that in, and notice that nothing happens. That's because this extrusion is expecting a mesh input, and I'm putting a curve in there. On top of that, this kind of operates on faces, not edges. And so it kind of needs some polygonal geometry to work with. So the way to get that and to fix this little info here that's popped up that doesn't give you any info is to add, let's go to curve and just fill it. So you can just drop that in between, and now suddenly we get our extrusion control, right? And we can run that offset into the input. So now we have extrusion control over here. Now it's not really looking like a phone that much. So what we can do is, now that we have this curve, and a curve is different from polygons in that it's already sort of math. It's like vectors versus bitmaps. We can add what's called a fillet to it. Maybe saying that wrong. It might be fillet. I'm not sure. And that will give us rounded edges. But in this case, it's not doing anything again because we're using this Bezier option on the curve, and we haven't really said what we want how we want these curves to be considered as a curve type. Before I go into that though, you can just toggle that to poly and then give it some face count. Oops, I'm doing it in reverse order. See how, look, we've gotten mesh here, so I dropped it in the wrong place. We want this to be first, and then we'll drop that in between there. Now we get our fillet. So we have Bezier, and you notice that the Bezier shows up hard-edged. It's not that the points aren't there, but they are. We just haven't given it enough points or enough curve. Right now they're just interpolated as straight lines. So what you can do is you can add a curve spline type and make that Bezier, and now we get this Bezier rounded edge automatically. The other thing you'll notice is on the fill curve here, I'm doing triangles versus an n-gon. It's probably better to stick with an n-gon, because if you do these triangles, later on we're going to want to be able to select these faces. And you can also see what's going on here with the extrusion of these lines. That's because when I ran this, let's see, Bezier curve rectangle. Yeah, when you do it by edges or triangles, you're going to get all these internal faces. It's just going to add a lot of extra geometry that and make selecting this top face problematic. So stick with the n-gons. I'm not even sure why the triangles are there. Now you'll notice when we did this extrusion, a normal extrusion on polygonal geometry will have a back face too. This one doesn't, because it's literally taken this face and just bumped it up and left like the edges, and it didn't duplicate the face down here, because a lot of the times you may not want to duplicate that face. But in this case, since we're making a phone, we do want that face. So all we have to do to fix that is take where we're doing the fill curve here, duplicate it, run that, and then we need a way, you can't just like run two meshes into the output, it's going to swap between them. But you can see where now we have this back face, and then here's our extruded face, but they're not combined, so we need a join geometry. Put in there. Then we can just notice that the difference in the input here on the join geometry is that it's got this big long pill shape versus the dots. And that means it can take more than one input. Now we have both faces and the whole shape combined, and we can control it parametrically. So if we wanted to make our width narrow and the tall, the cool thing about doing it with curves is if we were scaling this after the fact, so if we took this geometry and we applied a scale to it, scale elements, and we only wanted to do it on a single axis, watch what happens as I scale this on the y-axis. We want it on the y, not this. If you look at the curves, see how they flatten out and they don't stay nice and rounded? By making the scale come from the curve itself over here in the quadrilateral, we maintain this fillet in a way that it scales appropriately. So if we go notice that the curve stays the same. Now here's an issue. When you scale too small, you get this overwrap on the curve, and you may want that because it's kind of cool, but it's also probably causing some inverted faces and things that we don't want. The way to fix that is just turn this fillet curve. There's a limit radius, and now it will never go past the points where it starts to combine, and that's how you can get, like in our case, the iPhone buttons and the shape, however, whatever you want. All right, so now we've got this phone. Let's put some materials on it. And I want to illustrate some points about the way it's been built. When we made this duplicated fill curve here, we did it where the normal, i.e. the direction that the thing is facing, is the same as the top face. And normally when you have geometry, back faces face backwards, and top faces face forwards, or forward faces face forwards. They're all facing out from the inside so that you get this, the normals look right. You can see the effect of that if we take and merge these points, because right now they're separate. If I made this thing and baked it and grabbed just this face, I could pull it away. In fact, I can take that face and shift it off. Let's do a transform on it. And just move it down or up like that, because they're still separate, right? Now I've created two faces. Just to illustrate another point, is like you can pull and use a source as many times as you want when you run it into this join geometry. Each one will be considered at the point that it is transformed. So in this case, I'm using this fill curve and running it straight in, and that creates the back face, and then I do a transform and run that straight in, and now I've got another face. You'll see that a lot in this phone setup too. So let's say we want to make this thing watertight, solid, and not have these be separate faces. You can use a node called merge by distance. And putting that after the join geometry, then it takes these and takes the points, since they're joined, and merges them to become solid. The problem now is, because this normal is facing the same direction as the top, it's inward facing. If I do something like a smooth modifier on this, and you have to like literally tell it to smooth, you get this weird normal on the bottom. See how it's sort of got this weird tension and bend to it. That's just, and it's dark, which is because it's inward facing. On top of that, if you had materials that were back face culling, this thing wouldn't show up. The face would be lit from the inside. So the way to fix that is just to add a flip face right after you fill the curve. And now you can see, still a little weird, but you can see where the edge is cleaned up and the shade smooth is actually working correctly because it's smoothing these edges. And you can tell that it's not, what happens with these is because it's, I like to call it tension, where we've extruded this thing, and as we extrude this distance, then we've got this really flat surface up top with nothing to really tell it what's going on in terms of the normals. There's no edge breaking angle or anything like that. And what happens then is you've got this hard 90-degree bend, and that ends up, it kind of guesses at the normal, it kind of averages the normals across the surface. So you get this rounded, weird bump to what should be a flat surface. You can fix that a couple of different ways. You could do an inward extrude where, so like if we take this face and we wanted to clean up this edge, a modeling way to do that would be to take and just do another extrude mesh, but don't give it any distance. Just let it extrude right on top of itself, and then scale that instance just the face and scale it by like 0.95. Nothing happened. Why? Extrude the mesh, flipped it, extruded the face. Just to make sure, yep, there it is. Oh, I was setting my center as that should be 0 actually. It's local space. And now what you want to do is 0.95 on the scale. That should create that tension. So I'm scaling. Let's do like 0.9 just to make it obvious. Is it scaling? Oh, it's not an instance. My bad. I get into this working habit where it's like there's 2 ways to make geometry. You can instance on like points and use an instance to point, or instance on point, so you can like spawn geometry on faces and stuff. So I set this, and I use this a lot in the phone, but this isn't an instance, it's a mesh. So the way that would work is you need the scale elements, just the face, and then you want to use that top face. If you do everything, it's going to scale everything in the mesh. So let's just show what that looks like. So if we run that, then if we do a scale, if you do uniform, you'll just see where it's going to scale that face in, because it hasn't been merged yet, right? And what that would look like is this weird hole thing, right? But instead, we want to scale just that top face, not the sides. And make it 0.95. So it's tight. You can see where that starts to close that normal gap, and it gives it a little bit more geometry to figure out what this big, huge face in the center should be. So you can create kind of rounded bevels out of flat things that way. You could shift this just a little bit to create a bevel. So like 0.01, so it's a little bit up, and make it like 0.99. Then you get this nice rounded bevel from just that edge. And even though it's like hard edged, because it's smoothed, it ends up translating like a bevel and looks like that for low poly detail. You still get a little bit of a tension there, so you could do more, but in the end, you can just crease it or do something after the fact. So anyway, so let's apply. Just want to show you how to apply materials here and there. So let's make a couple of materials. We're going to make a back face material. We'll make that kind of metallic, rough, and give it a color. And then we'll make a side face. And give that metallic, be a less rough, and be a little darker. And we'll go with a front bezel, the dark spot around the screen. Bezel material. That'll just be black. And since it's glass, will be super shiny. Then we'll do a screen material. So 4 materials. And that can be bright and emissive All right. So we haven't applied those, and they, notice I put them on the geometry. It should have at least turned that first material color, but because we're not piping in the original geometric info from here, we don't have any reference to a material to apply. But what you can do is you can apply the materials as you create the parts. So we can do a set material node. And let's put this one, since it's going to be on the back face, let's put it here. Call it back. So now everything is that back material because it's the only material that we've applied. And we've applied it to everything in this setup. And we're joining here. If we wanted to target something specifically and leave it just to see it, we could just say, oh, let's just put it on the top face. And now we have the white material, and then we have this back face material on the back. What we want to do is let's lose the scale and the extrude because the bevel's not working for me. And run this mesh here. And let's lose the shade smooth for now. Might bring it back, but I like to work with hard edges. And I'm going to turn on geometry so we can see the edges. Wireframe, I mean. Okay. So now again, everything is blue. But, and we don't really have a selection to pipe into it. There's no place that's got an output for this selection, right? This extrusion does, but that doesn't reference this geometry that we're using up here, okay? So the way we can select that geometry and figure out what we want to do with it is up here. You'll notice we've got this spreadsheet. You can select for faces, and you'll see the options for how the faces, like what's being generated here. And you'll notice the shade smooth. You can use that to toggle. No, you can't toggle it manually, but you can set your shade smooth and find these targets here. There's also an add-on that'll show you the numbers, the indices for each element of the geometry based on these. And what we want to do is we want to target whatever index it represents these faces to only apply that material there. We don't have to do that because if we take the set material and do this and apply this one to the extrusion, we can just make it the side material. Now we'll have a side material. Let me turn this so that it is facing 90 degrees. Here's our back material, there's our side material, there's our front material. If we want to apply a material to just this front face, like the bezel, we can duplicate, select the top, and apply the bezel. So now we have back, side, bezel. We don't really have any place to put the screen material yet because we haven't made that screen. But that gives us something to go on. Now on an iPhone, you'll remember, if you look at them, they have kind of an extruded thickness to this side, which is cool because we can actually make another extrusion. Run this here. Come back and apply that. And now that we've got that extrusion, notice it's extruding in all directions. And they're also disconnected. So you want to turn off individual. Now it's just made everything fatter. And now we only want to extrude just the side so that it only extrudes out. And then you can change that thickness like that. And now we have our thin metallic case. And we still are targeting that geometry with the side material. And we have our bezel, okay? So let's talk about like if we wanted to target this back face, since we don't have a way of doing what we've done with these extrudes here where we have a top and a side, and we want to target this back face to put something on it, like our camera module. The way we can do that is if we create an index, which is just an input, and then we need a math node, in this case a compare. And we're going to, since the index is an integer, we're going to make it comparing for an integer. Run the index into the A, and notice that we do get a result out from this compare, so we can do something with that. So let's do mesh to point. So we're going to create a point on this back face that we can put something on. So we'll make search mesh to points. Notice that it takes a selection and a mesh. So what we want to run in is, well, for that matter, since it's a separate face here, not connected at this point, we could just apply that. And it would still find just the point, because the only part of the mesh at this point that exists. Well, yeah, because we haven't done any combine the extrusion and stuff, so the only thing that we're sampling here is that back face. But if that back face had more geometry to it, then we'd want to do something like this. So let me go ahead and just do a let's make it a grid so we can see what's going on here. So if I add a subdivide, mesh here. Yep, it's a mesh. Oh, I'm not doing the output yet. If I run that in flip faces, you see where it's now subdivided and I have lots of polygons. Just do one. It's not necessary to do that, but I'm just doing it to illustrate a point. So now that we have this greater than integer selector here, I can run that into the result and then do something with that. If we just do the points, it'll show them, but they're not going to show up great. But you can see where it's creating these like invisible points, in this case on the vertices. We want to do it by faces. So now we're doing like integer greater than 0, which is all of these faces. So if we slowly crank that number up, you see where we start to call out some of those points. Let's say we want to target this center vertex that we've created. Or let's not, it could be that this thing is like, again, it could be this extrusion. Maybe I should do it on the front because I haven't separated that face, but then I could just target that face. So let's keep it on the back. Let's put a cube on this thing just as a reference for our camera module that we can move around. I'm not going to go through how it gets extruded and how I created the complex shape for the actual iPhone, but I'll show you the gist of it. So let's take our quadrilateral set spline and fillet, because we're going to use it again. Duplicate those and pull them up here and run those into a create curve. Let's see, curve to mesh. So what this does is it takes this curve and runs it in. It wants a profile for the extrusion because you can change the way the profile looks. In fact, this is the profile, sorry. Run this, and then you run it along a curve. It could be a spiral or whatever. and then generates that. So what we want to do is put that thing where these points are. So let's create a points mesh distribute points on faces. No, that's random, sorry. Let's go to our points, instance on points. There we go. So this is something that you'll end up using a lot. The power of it is you can create geometry and then snap that geometry to some face, point, vertice, line, whatever you want to put it on. So you run this curve into the instance and you'll run this point to the points. So we're generating these points. So it's going to put these instances on those points. We can disconnect this. And now you'll want to use the result here. Actually, you don't need to use the result because you're generating the points. If you wanted to fine-tune the selection of those, if you have a lot of points generated, you could run a selection mask into this and then further refine it. If you wanted to mesh, not do the selection here and do the points on everything and then just say, well, I just want to put the instances on these points, you can do that as well. Either way will work. All right, so now that we have that, we can put that back into our geometry, instance on points. Nothing's happening because we haven't given it a line, an actual curve to extrude on. So let's create a curve line. Primitives and line, yep, here. Now we've got a whole bunch of shapes getting put on our curves, and notice that they're extruded hollow, right? So here's one way you can do what we were trying to do before, where we didn't want faces and you end up getting all this, and this is actually how I made the notch on the phone. Right now these things are too big, so let's change our curve size to 0.1 and 0.1. So they're a little bit smaller, and our length, which is the extrusion here, to 0.2. And you'll see where it's putting them on, these curves are on the spawned points, but they're going in reverse. They're extruding in an opposite direction. And that is because I think, yeah, I did the I'm connecting to this before the flip faces. So if I do flip faces here, let's keep the subdivide and then run. Yeah, let's just do it this way. Oops. If I cut this, it's going to lose the face, and now you see those shapes. So we want to keep that face. I am flipping them now, running them in. Okay, let's do this. We'll add the set material here. And then we'll add another one for in between. So what's going on is it's extruding. I've got this subdivide just so I can generate more points. I'm going to pull that out and show you how that works in a minute, but I need to get them facing the right direction. So our curve, we filled it, limited it. Here's our, let's go negative. I'm guessing it's probably taking like a hard-coded end in terms of the dimension, and it's because we're going on the z-axis negative, it needs to go in that direction. So there's our curves extruded. Let's make it slightly bigger. Still rounded out. So that means we need to make our fillet smaller. So we get that rounded corner. We can do fill caps. Make it less 0.05. There we go. Now we don't want all of these shapes projected on our phone. You might. There might be some reason why you want it. Because it does create kind of an interesting extrusion overlap of its own, and you can do things to regenerate the mesh and create that kind of shape. But basically we want it just in the center. We want to be able to position it. So let's lose the subdivide. But this is just to show you, like, we can create, use this kind of an indexing mask where we can say equals instead of greater than, and negative 11, but now you'll see where we can move just one face, because it's just going to equal that only once. And we can move that shape around so that it centers on that face. So you can use this kind of index selection. When you know what you're dealing with, if you end up having some sort of procedural geometry generator up front, up here, that's going to generate a lot of faces and you don't know the exact count, this isn't going to amount for much, because like your position, because the face count's going to change, and if that index changes, it's going to put it somewhere you don't know where it's going to go. So in our case, we're just going to deal with this single face, so we can just lose that subdivide, and let's see what happened then. Yeah, because we don't have the selection. We don't need it now. So now it's just doing the single face and placing it smack dab in the middle. Okay. Snapped on top. If you wanted to position that relative to the camera, you've got this rotation and scale here, but you don't have really like a position mover. But remember, I accidentally added the translate instance. We can put that here now, since we're actually using instances. And now we have the ability to put some math nodes here and actually translate it as a kind of percentage of the height and the width. So if you add the math, and we take our height or width into here, and then multiply it by a say like 0.1. Well, actually, it ended up being a little bit more complicated, because we've got to take in the half width of the square so that we don't shift it off. So I'll show you what this looks like. We need a combine. We've got to put in a vector. So we need an XYZ, combine XYZ. And we can just run this into the X and then run that into there. And you notice how it's like 0.1. I'm doing an add. I want to multiply. So I take that original number and so like 0.34. And what's happening is it's placing it like center point 34% across, right? So that's going to shift it. But the advantage then is that when we scale it, that moves with it based on a kind of percentage. But notice that it's not great, because we're not scaling the camera node itself either, and it'll scale off, and it's kind of hard placed there. So what you can do to fix that is just do another multiply, where we take the be probably like a subtract, where we take the width and the height of this thing. In this case, they're both the same, so we can make a value. So we can pull this off and run that into there, 0.3. Oops, like that. And then run that into this here, and it would be something like, in this case, multiply by 0.5, so we have the half value of it. So then what we want to do is subtract this from this so that it shifts halfway. So that'd be another math node. We can just duplicate one of these, subtract. It would be this one from this one. Now it's, notice that it shifted to the right, so now we can move our gotta run that in. So now we can shift closer to the edge, and then as we scale our width, it'll stay that percentage relative to the edge. And we can do the same thing for the height. Notice it's getting crowded here. Sometimes I'll close these up if they don't have too much to do. So we'll just take two more of these. Close these. Same thing. So then we go from the height. Which one did I do? The bottom one. And in this case there was a difference, run that into there, subtract one from the other, and put that into the Y. So now we've got sort of up in the camera notch position, and we can change the offset so that we're not so, oops, that was their distance. I've got to change the fillet here. So we've got our camera fillet. We can run that in as another input, so that we can make it more iPhone-like. And we can do the same thing on these other curves. We can make this camera notches fillet a percentage of the actual phone fillet, like all kinds of procedural things, and start to play around with it. But I just wanted to give you kind of a general idea of how I went about constructing this phone. Let's do the cool trick, one more cool trick here for the how I created the notch, the ability to cut out the notch, and then also do the phone screen, since we have that material waiting to be used. So now that we know how to place something on a surface and position it, like we've done with that camera notch on the back, let's do that to create a cutter for the screen on the front. So if we take our quadrilateral, just trying to think a sec, yeah, we'll do all of this, duplicate it again, and instead position it on this front face. So we'll want an instance on points, and we will want the bezel shape here, face, which should be the top selection from here. So if we run this as our mesh to points, where is it? Here, make another duplicate of that. mesh the points from this, and we want to run this top face selector as the selector for the point to put it on. And then we can push that point into our instance on points, and we're going to instance this curve. And just so we can see it, I want to, let's go move this stuff. Let's make another join geometry just so we can target it. Because we may want to combine things up here and then run those into this. So now you see we've got our kind of our shape extruded on the top. We don't want to go negative. We want to go, let's do 1. Yep. Because we're going to just cut this face with that. We don't need the fill caps. All right. So now we look at it straight on. We can scale this to basically be our bezel size. And then play with our curve radius so that it matches. Like that. And take and do the exact same thing again on the same point. Yeah, we're going to do it on the same face, but we're going to do another instance to points for that one. We're going to take all of these and do it again. You're going to be like, why am I doing this? Well, it's a pretty cool effect once you get it to work. And I was kind of surprised when it actually happened the way it happened. I was expecting something different. Now we've got the exact same shape on top of itself, but we're going to use this to make the notch. So we can make it smaller. Then we can play around the bezel or the bevel. Now we've got this notch shape, and we want to like shift it up and put it on this face instead. So instead of using the camera, we could position it manually, but it's better if we, since we know we always want it to be relative to this top face, if we can just do our little math selector index and find that face. So what we can do is grab index again and do our math compare integer. Run that into the top. And what we're going to check is we're not going to use this mesh to points coming from the face there. We're going to use the instance that we created, or this mesh to points. So not this one, but this one. Notice that it's going on all of the points because we don't have a selection. And yeah, if we go run that into the selection now, and we do, notice that we start to cull a little bit. Now it's placing them on the edges, and we want it to be placed on this back edge. So we also want it to be only equal to, not greater, so it'll have to be like an equal one, and so we can shift it around. So we're using that as our selection for the point, and we're curve to mesh here. Curve to mesh, so we're, let me think about this a second. Yeah, so it's got to be mesh to points faces. So we're missing our, we're not doing our mesh to points coming off this curve. So we need that. And then this will actually pipe into that selector, not this one. And we want it to be based on edges. Notice now we're hitting that back edge and we can, and it overlaps, right? So now we can shift our numbers to find the center, right? There. Okay. Now, again, because it's centered and not perfect, we may want to actually shift this up a little bit so that it and I had to do this on the phone, but we can do that with our translate. So switch translate instances. Now we're just going to bump it up on the Y. That. Okay. That'll be like where our notch goes. So how are we going to cut this out? Could just cut it as is and it would cut into this face and have like this top edge, or we can do the thing I was sort of surprised about. Did I shift it? Is it shifting back? Trying to figure out why it's not the same scale. Let's see, wireframe. Be the edge. Maybe I do want to align it by face on that top face center. Let's do that instead of edges. There's going to be less faces than there are edges, so our count's going to go down. There we go. Notice that it's centered. Oh, because it's an extrusion, that's why. So I do want to do it based on the edge. I'm not sure why it was offset. Might have been just hitting the wrong edge. See how it's offset there? Shifts forward. So that's in the center. Let's see if we can account for why it's offset like that. Because you can see it's the same amount. Oh, because it's doing it from 0, not... All right, so in that case, we just need to shift it by the amount of our extrusion. All right, so yeah, I can't remember how I counted for this, but it's an easy fix. So we just need to shift the Y, not the Y, not the X, the Z by our extrusion amounts, which I think is called offset scale. But in order to pipe that in, I'm going to need to push this into, so if you let off here, you can put a XYZ combiner, and it'll automatically just generate the connection between the two. I'm going to make this a node and run that into Z instead, and then take our 1, 2 on the Y and put that in, and then I can just run this vector into there. Now everything lines up. Okay. Now, why did I do that? Because I want to get a clean Boolean between these two now before I pipe them into this join geometry. So let me add a mesh Boolean here. Notice that it's going in, like, this is going to be an interesting little trick here. Because this is an instance, you can't run it into this mesh part, but you can run it into the second part, which is weird. I don't know if that's a bug. It's something I figured out. And then the order of execution that you have these stacking in the second part actually still does the difference. So you don't need an original source mesh. You can just stack them on the bottom. It's like a Boolean for instances. So what you need then is that one, that instance, and then this one. You can see where the order changed. So what we want is to grab this top one, put it on the bottom, and you see where our cutter starts to work. All right. So that's how we create our notch in an additive way. Could be intersect. Move one. I don't think they. Yeah. So it's going to be difference. You got to get their order right. There we go. All right, so that'll be our cutter for the notch. Did I lose my translates? Yeah, I did. Move it up there. All right. Now, what do we do with that thing? Because it's not making a screen yet. What we do is because it's sitting right on the edge here, we need to shift it back a little bit. The result of this Boolean. So that would be transform. And just make it so that it goes through that screen a little bit. It can go a lot or a little, it doesn't matter. And then we can do another mesh Boolean where we take, where's our bezel? Here, this, instead of running it into this join geometry here, we can run it into a mesh Boolean. And then run this one in to cut it. And you're left with that hole, bezel hole. It's not quite right. What's going on there? I'm taking set material. Oh, because I'm getting the entire extruded mess, and I only want that face. Well, no, because I'm only. Yeah, I'm taking all of the geometry, so I need to create a separate face for that. And that would be coming from this guy. So we'd make a search separate geometry. And so we've extruded the sides here. We don't want that. We want, well, yeah. That geometry this. Yeah. So we want this face top here for our geometry to work with the screen. And then we want to delete that exact same face so that when we double it up here, so we can take these guys out. Yeah, the side material we still need, so but yeah, this we're going to run here. Now notice we've lost our side because we're not running it into our join geometry anymore, because we need to delete the same face that we're making a copy of first. Face, so we'll delete that and it'll be the same top face, and then run that in here so we can get our sides back. So now we've essentially separated the screen off and gotten rid of it. So we've separated it to make a copy, run it up into this mesh Boolean for the difference, and let's see if we can change the order of execution. Let's make a copy. Nope. Same effect. Didn't mean to do that. Run that in at the top. All right, so there's our notch, but we also want a screen as well. We're also missing our bezel. Why is that? Anyway, I don't want to go into too much detail. I'm starting to run out of time, but we do need our screen back because we've cut it. So we kind of need the original, but in the inverse. So what we'll do is we'll take another mesh Boolean, and in this case we'll invert this, so the method. Let's make a copy or a splitter here, and then come back with a join. But we don't want it that way. We want the intersection, I think. Notice that I'm missing part of my bevel. It's partly because of what's going on with the way this geometry is intersecting on the here. I believe what I need to do is scale. Let's see. Grab this and make it front. Nope. There. Now I've lost the bevel, but I've got my screen back. Notice I like to split these so I can keep my points and not to drag like long curves. Then I can cut these and try a different arrangement. So there's the bezel. That difference isn't working. It works differently on the phone. Oh, I'm getting a mesh Boolean problem, so I need to, it's got to be that way. I believe it might have to do with the way I had to reposition the instance on the translate. It may have a little bit of a rounding error, and they maybe not overlapped completely, and that's why I'm getting a different, because like when I did this before and I had this cutter working, when I did the difference on the two, it literally gave me just a clean cut with no top edge there. But I think because this is going like that, because it has that hard edge up there, I'm missing the bezel piece. But you could see where I could get that back by doing another and running these same objects in a different way to get that piece back, and then I can join it back up. Now I got to get that piece back. Let's see. Was it a difference or was it intersect? I think. W to move these around. It's not intersect, it's definitely difference. So I'm combining, transforming, and doing another mesh Boolean with the screen. So really I need it's the opposite. So this one's running in on the bottom. So they're both running in on the bottom. So I need to do that. Yep. And then maybe run my second screen. You can see how complicated this gets. So what we can do to see if we can switch it. Nope. Cut those, cut that. Well, we need to cut this short, but you see the idea. I can show you where on the phone setup how that works. Really all we have left here is to put in another set material. For the screen. Now I'm setting it on everything because I lost where I put it. Maybe I set it here. That's the inverse. Here? Yeah, there we go. So now we got our screen. We're missing our bevel, our bezel piece, or our notch, I mean, which is problematic, but we can get it back with a little thought. I just don't want to go into too much detail. What I'll do is I'll show you how it does work on the phone. We'll wrap it up. So if we look at our phone, you see where the geometry, let me turn on, yeah, how it's clean and there's no edge there. That's because that bezel is coming from these two quadrilaterals. Maybe that's the reason. Maybe it's because I generated a second quadrilateral that was essentially the same, and it was because I needed to scale different amounts on the width and the height to get this, because it does have a different radius on the bevel. So I've got two different fillets. I'm running those curved to meshes, and then instance on points. And now here's my mesh Boolean with a switch, where on one I do the Boolean, on the other I don't, and that basically gives me the ability to toggle the notch on and off like that. And if you ran this, which one? Yeah, here's the difference. So if you ran this into trying to figure out which one I'm running for the oh yeah, so these two, if you just ran this mesh into this join geometry so we can see what's going on, you'll see what that toggle looks like. You see how it's clean when it did the join? And also I was able to run both in without getting that mesh Boolean to have an error. So that might have been part of the reason that it worked differently. But yeah, so it comes in clean and I'm able to, if you look at the toggle, well, it's turning it off, but it's not changing the shape because it's just either using it or not, the mesh Boolean. So yeah, anyway, that's how that works. Hopefully you found this video useful. Oh, let me just go through a couple more details. I talked about how I did multiple approaches, and I didn't really get into using what I'm using here in terms of the, I've got this, let's see. I've got these control planes that I'm using vertex colors for. So if you go into vertex paint, you'll see these control planes where I've created colors and I'm applying those as controls to map objects to the surface and do Booleans and stuff with. So that's one way you can do it, and those will like travel with the object. The problem with it is like when you get into a lot of shapes, it works fine for a few shapes like the cameras. In this case, I'm duplicating these two cameras and I've got this different camera here and I've got a pre-modeled flash that I can position that way. So if I go into edit and select those faces, the way I've mapped it out is I can scale those up and down. I can duplicate them and move them around and make them, put them somewhere else on the object, make as many as I want, as long as they have this the same control data, vertex color. The problem is like when you get into a lot of shapes, like all of these bevel, these button cuts that are different sizes, you end up creating a lot of colors and you have to have a lot of node setups to account for the difference in sizes. So what I did instead was I made a kind of kit bashing approach where I created a bunch of instance groups, or not instance groups, collections. And then, and notice I call it kit bashing setup down here. I take and put objects of a type like buttons in those, and these are just generated with more geometry nodes setups that are kind of the same thing I used to make the body, but in this case I just make the button, apply a material to it. And then I take those and I can just duplicate them and position them relative to the body, and then I do stuff. So like I pull all the objects from that group, in this case the buttons, I kind of inflate it with this ETK solidify node, which makes it bigger, and then I do a mesh Boolean to cut the hole in the mesh here in order to make it kind of sink in, and then I also duplicate that object without the inflation and then add it back in as the button, and I can move it around so I can grab these buttons. Now the difference is these have to be manipulated from the scene. So if I hit W, it's this button here. I can rotate it. Let me see. Oh, I was in edit mode. I need to be in object mode. So I can rotate it, do whatever. Duplicate, position them. So it's more like kit bashing, but it's kit bashing with like booleans and stuff. Notice that they're overlapped because I'm making instances of these in the mesh, and that way I don't have to have these turned on. So when I turn them on to position them, you see them duplicated. When I hide them in the object, they're hidden, and it works. The issue with this approach is if I take the entire phone and move it, the buttons stay positioned where they are. But notice that my vertex color stuff that I'm positioning travels with it. The orientation for this isn't translating with it because it's something in the setup. But for my purposes, the way I made this phone, this is fine because all I have to do to get everything to travel together is just duplicate the phone, apply. So I've got a second phone here. Apply the geometry node setup. Gets rid of all the nodes, but now everything's married together, and I've got my phone. Okay. Just different ways to do different things. In my case, I wanted to have certain setups that I could control easily from the geometry node setup, so I could make variations on this, like make an iPad from it or whatever. But I didn't want to go so far to create like tons and tons of controls so that it all sort of stayed together and I could leave it in geometry nodes, because I don't need to leave it in geometry nodes. I'm just using the geometry nodes to make certain things procedural so I can scale it to make different camera setups, different sizes, different colored metals, whatever. And then just duplicate that, and there's a version of that phone that I can go and optimize and use for whatever. Okay. So anyway, that's how I've gone through and sort of pieced out how to use geometry nodes in a kind of art pipeline type of approach. Hopefully you have found this useful. If you have any questions, just leave them in the comments.